All right, let's take a look at using these three rules. And I'm just going to stick with our 4 minus x squared and say that we're just going to try to integrate it from 0 to 2 with 4 divisions. So same as before, but we'll actually work it out. So we are looking to, let's get the pen working. We are looking to integrate from 0 to 2 4 minus x squared dx. And we'll approximate that with 4 divisions. As I do this in this video, I'm going to do it more or less by hand. But I'd really encourage you to use some technology. A spreadsheet like Excel or Google Sheets can make your life a lot easier here. If that doesn't make your life easier, feel free to do it by hand or with your calculator, whatever way works best for you. It's going to be most efficient for you. But on the homework, I'm totally fine if you turn in some, cut and paste spreadsheet work. Okay, so let's start with the midpoint rule. And just as a reminder of how they wrote that in the formula, they'd say M4 is the notation we'd want to use here. So we're looking at doing a midpoint rule with 4 divisions. And that would say that's calculated by delta x. So we know for 4 divisions, delta x is 0.5 or 1/2. So 1/2 times. And then we just need the function evaluated at each of the 4 midpoints. So that would be the first midpoint is 0.25. And I put a little table down here. So you would do 0.25 plugged into the function. So it'd be 3.9375 plus next midpoint 3.4375 plus next midpoint 2.4375 and plus last midpoint 0.9375. Okay, and you would just crunch that together, and I'm not even going to do that, but that would be your midpoint. All right, so let's go ahead and move on from midpoint to see if we can evaluate the same thing with trapezoidal rule. So for trapezoidal rule, for trapezoidal rule, now I lost my train of thought. Okay, we need to say, hey, our division, our x, delta x. So first of all, we're doing trapezoid rule with 4 divisions, T4. And that will be equal to our 1/2 or our 0.5, whichever way you want to write it, divided by 2. So really that's going to be 1/4 right here. And then it's going to be f at the first edge. And keep in mind with trapezoidal rule, we're back to using the edges of the bar, not the middle. All right, so this will be, for us, that would be 0. All right, so now we're at 0, 0.5, 1, 1.5, and 2. We'll use those for trapezoidal rule. We'll use those for Simpson's rule as well. Anyway, so we need the function evaluated at the first point. The first point is 0 for us, and that's 4. So 4. And then we need 2 of the function evaluated at the next point, which is 0.5. So 2 times 3.75, that's this term right here. And we need 2 of the next one. So let's see, we're at 1 now. So 2 times 3. And we need 2 of the 1.5. So 2 times... plugging in 1.5 results in 1.75. And we need just 1 of the last points. Plugging in 2 gives you 0. So just to be formal, I'll put the plus 0 on there. So again, 1/2 divided by 2 is really 1/4. But you've got 1/4 times all that added up. And again, I'm not going to actually crunch that out, but that would be the trapezoidal rule. And let's move on to using Simpson's rule. So Simpson's rule is the most complicated, but still not that bad. We know how to do Simpson's rule with 4 evaluations. So our delta x, we're still covering the space from 0 to 2 with 4 divisions. So that still means a delta x here, right? This is a delta x. Oops. Our delta x is 0.5, or 1/2. So Simpson's rule 4, S sub 4, is 1/2 divided by 3, which is 1/6. But then again, we're going to do, and this is using the 0 and the 0.5, those points. So we're going to do 1 of the 0, so 4, plus 4 of the next point, so at 0.5, so 4 of 3.75s, 2 of the function evaluated at the next point, so at 1, so 2 times 3, 4. Yeah, I'm just going to skip down here. 4 of the next point, which is a 1.5, so that's plugging in gives you 1.75. And we're actually here. We're on the second to last point because there's only the 2 left. So we just need 1 of that last point, which is, again, is a 0. And Simpson's rule, as you start running through it, again, your second to last as you go 4, 2, 4, 2, 4, 2, 4, 2. Your second to last one, it better be a 4. Otherwise, you weren't using an even number of divisions. But again, you crunch that through, and that would give you the Simpson's approximation, which, since we're integrating a parabola and Simpson's uses parabolas or quadratics, this one will be completely accurate. But that's the idea for using midpoint, trapezoid, and Simpson's rule to approximate the value of an integral. So again, on the homework, do this as efficiently as you can. Make a table with a computer or something at least, and crunch those numbers as quickly as you can.